Okay, let's work a limiting reagent stoichiometric sample problem. And we're going to get this one from a website which has a bunch of really good sample problems. Gives you very quick feedback. On this particular one, we're going to work from sample set 14. And we're going to take that question right there, question 6. So here's what that looks like. Dinitrogen pentafluoride was once considered to be an effective oxidizer in rocket fuel, and it's produced according to that balanced chemical equation. And it wants to know, starting with 24.4 grams of ammonia and 80 grams of fluorine, what's the limiting reagent? How much of the product are you going to produce? And of the material that is in excess, how much do you have left over? So, here we go. We're going to move fast. Feel free to pause it. We're going to write our equation and write the amount of material over each reactant and designate the product that we need. We're going to call it A, B, and C to keep our little dimensional analysis clean. And the first thing we're going to do is see how much product can be made from reactant A. So we're going to go through our initial dimensional analysis setup. And this reads, box, how many grams of C can I get starting with 24.4 grams of A? First step is to go from grams of A to moles of A. There. Next step is to go from moles of A to moles of B. There. And finally, I'm going to go from moles of C up to grams of C. And now I've arrived at the box. I'm going to have to come up with the molar masses. So I guess I'm going to need my periodic table and the values for hydrogen, nitrogen, and fluorine. So NH3 comes out to be 17.0 grams in 1 mole. From the equation, I can see there's 2 moles of A for every 1 mole of C. And finally, the molar mass of N2F4 comes out to be 104. I'm now going to punch that in my Desmos calculator, and I'm going to punch it in a way that pretty much resembles the way the dimensional analysis looks, and I get 74.6. Then the next thing to do is to make the same calculation, but this time from fluorine to our product, starting with 80 grams. Again, our setup, how many grams of C do I get starting with 80 grams of B? As before, I'm going to march it from grams of B to moles of B, from moles of B to moles of C, and finally from moles of C to grams of C. As before, filling in the molar masses and looking at the ratio of 5:1 on the chemical equation and punching that out on the calculator. Gives 43.8 grams. And recall that the limiting reagent is the one that gives us the least amount of product. And so in this case, fluorine B is limiting and ammonia is in excess. So we now know the maximum number of grams we can make, 43.8. Well, the question also asks us something else. How much is going to be left over? Now, 24.4 is what we started with, but what we don't know is how many we actually used. So we're just going to do a back calculation to calculate that. We're going to calculate how many grams of A did we use to get 43.8 grams of product. And again, it's a similar setup. We're going from C to A. Our setup reads, how many grams of A do we need to make 43.8 grams of C? And once again, we're going to just take our dimensional analysis path and work from the starting point to the square. Here we know that the molar mass gives us, there is 104 grams of C in 1 mole of C. And next we're going to go from moles of C to moles of A. We do that using the coefficients of the balanced chemical equation. And you can see there's a 1 before N2F4 and a 2 coefficient before ammonia. And finally, we're going to go from moles of ammonia to grams of ammonia. And we'll use the molar mass to make that conversion. And once again, punching all of that out on the calculator tells us how many grams of A was actually used. In this case, we come up with 14.3 grams was actually used. It's a simple matter to finish up. We started with 24.4 grams of A. We only used 14.3 to make our product, and so we have 10.1 grams of A left over. And with that, we've completed all of our calculations. We have determined the limiting reactant by determining which reagent produced the least amount of product. And from that, we learned that the max amount of product that can be formed is 43.8 grams, and our excess reagent is going to have 10.1 grams left over.